Welcome. We're looking at task 9.5. The factors that we're looking at is how much fish versus chicken and weekday versus weekend. And he's trying to figure out if there's more fish on the weekday or on the weekend, and is there more chicken on the weekday or weekend, or does it not matter? Because he's ordering the information. So first thing, let's figure out the probability of fish. So the total orders were 339. The fish was 153. So we're going to say 153 over 339. And I'm going to use my calculator and divide. And 153 divided by 339 is equal to approximately, so I'm going to use this to show it's approximate, 0.451, which is equal to 45.1%. So the probability of fish, regardless of the day, is going to be 45%. Now, the other thing that we want to think about is what is the probability of fish if it's a weekday. So the probability of fish if it's a weekday. So we're only concerned about the weekday stuff. So the total weekday, there's 144, and of the 144, 65 are fish. So we're going to do 65 over 144, and that's going to be approximately, again, I use my calculator and divide to get a decimal. Look at this, 0.451, which is equal to 45.1%. We could do one more, why not, right? So in this case, let's see, what is the probability of fish if it's a weekend? Or we might say, you know what? If it's the same on a weekday and it's the same overall, it's probably going to be the same on the weekend. But anyway, let's take a look. So on a weekend, we're looking at a total of 195. There's 88 fish. So we're going to do 88 divided by 195. And that is approximately, let me test it just to be sure, 88 divided by 195. And there it is, approximately 0.451. Which is 45.1%. So we're going to say that it's independent because it's the same probability for weekend and day of week. So people, when they buy fish and they buy chicken, it has nothing to do with what day of the week it is. It's just going to be people's preference. So when you're ordering, your order should be the same in terms of fish versus chicken, the same ratio each day. We can also do some other calculations, such as, let's do this, we can look at the probability of weekend and chicken. So weekend and chicken. So this, weekend and chicken, we go to weekend, we go to chicken, there's 107, and we notice it's 107 out of the, this case, the total, which is 339. And then the probability of weekend is going to be 195 out of the 339. So I've got 195 out of 339, and the probability of chicken, I look at my total for chicken, which is 186, so it's going to be 186 out of 339. And then what we can do is we can multiply those out, and here's what we should find. The probability of weekend and chicken is 107 divided by 339, and that is 0.3 0.316. And then if we take the probability of the weekend, 195 divided by 339, we get 0.575. And then we look at the chicken, which was 186 out of 339. We get approximately 0.549. And then if we multiply these, do we get 0.316? I'm going to try it. So I've got 0.549 times 0.575 is equal to 0.316, approximately 0.316. So this further confirms that it's independent, that it doesn't matter whether it's weekend or whether it's weekday. It doesn't change the probability of chicken or fish. So these are, in fact, independent. So to figure out the last question, how many, if you had 500 orders, how much chicken? Well, it doesn't matter what day it is. You would say the probability of chicken, which I thought we calculated, is 186 out of 339. So it's 0.549 times 500. And for the probability of fish, which was 0.451 times 500. And that's the order that we would have. So let's see what that is. 0.549 times 500 is approximately, it says 274.5, so let's call this 275 chicken, and the rest would be 225 fish. So 275, 225 fish.